Hi, this is Archit, and I'll be speaking on behalf of our team today. Our project is classification and detection of nuclei in histology images using convolutional neural networks. I'll first quickly go over the major idea behind this project. For details, please refer to the paper. I would like to take this opportunity to talk about the ideas that might not be mentioned in the paper and give details which might be helpful for future projects in this field. Currently, pathologists sit under a microscope to find and count the number of nuclei to predict if a person has cancer or any other ailments. We are trying to eliminate the need of sitting under a microscope by making a classifier which takes an image and gives out labeled cells. This would save a lot of time and money. Some of the challenges in this field are that not many people have recorded data with annotations, and as there is limited data, and that nuclei come in different shapes and sizes and have different backgrounds. Moreover, it's not even easy for humans to classify properly, hence, it becomes harder for the classifier to learn correctly. As this is a big data course, we wanted to use some of the big data technologies available. We chose to leverage the power of Spark. We pre-process all our data in Spark first and persist it. We want to use this data to first find the best convolutional neural network. For that, we load the data as a distributed list (RDT) and then generate a list of combinations of metaparameters that we would want to train our model on. At this step, we map a function over our RDT and the parameter combination list, where the function is to train our model in PyTorch with the specified metaparameters. In other words, we are using Spark as a framework to parallelize different runs. Each run is stopped once the validation error starts to increase, as mentioned in the paper. Later, all these results are merged using collect function. This is really cool as it saves us all the effort of creating or finding a framework to parallelize these runs, as in reality these could be way too many. We also used Docker to set this up, and due to the correct setup of the frameworks, we were able to divide the resources such that none of them interfered with each other, and it leveraged the multi-threaded capabilities of both PySpark and Torch. Docker helped us to scale. With it, we can now spawn a model on a machine with lot of resources easily and also recreate the environment every single time. Our results look great in my opinion, however not perfect. They do not look exactly the same because the way we did detection. On the right is the ground truth where we directly mark the nuclei as a spot. On the left we see some of the markings as lines or splattered spots. The reason is that we have not performed softmax technique, but instead we have used max. The image marked as A is what we use instead of the image marked as B. If you look closely, you will see that only green is majorly marked as lines instead of dots. This is because fibroblasts are elongated nuclei, and our model is trying to mark the whole cell instead of just the nuclei. Here you can see how well our detector is classifying the background. We do see similar splatter of red color, that is the epithelial nuclei, instead of dots, but the location of them is on point. Here we can see that the data input has some issues with it. Not all images are annotated completely. While our image is able to find the labels, we do not know if they were actually correct or not. This also accounts for some incorrect values in our high false positive rate, as our model thinks these are correct while we have no ground truth for it. Furthermore, we do not know in reality if these are actually correct or not, and we cannot just remove them from our calculations. Based on experiment and research, it looks like an easy problem to solve and scale. With more resources, we should be able to try more complex models, and once we have more data and better annotations, we should be able to get great results. Thank you.